these a little bit quicker here. So we're going to write the equation of the line again. All right, we're using the graph. Use what you have. Remember, when the x value is 0, that's actually your y-intercept. So we need m and b to write the equation of the line. We have our b. We have our y-intercept. Again, scales, because of scales, you're going to have to use the actual slope formula to find the slope. So I'm going to go 51 minus 50. That means I'm going to go 10 minus 0, which would be 1/10. 1/10 is my slope. I have what I need. All right, now I just put it together, find the equation of the line, and we have y equals 1/10 x plus 50. So we did the algebra. Now let's read the graph and figure out what the slope and y-intercept mean. This graph shows our cell phone costs. All right, the x-axis is the number of text messages sent. And then the y-axis represents the cost of your cell phone. So let's start with the y-intercept actually. So we have slope and y-intercept. I want to figure out what they mean. If you've sent 0 texts, your phone costs $50. So you have a flat rate. So your phone costs $50 before texting. Now the next part, the slope, is going to tell us what happens when you text. So what it says here is for every 10 texts, your phone bill goes up $1. So for every 10 texts, for every 10 texts, your phone bill goes up $1. All right. So it depends on how much you're texting. If you text 20, it went up $2. 30 times, it goes up $3. So on down the line. So that's what we have is the meaning between slope and y-intercept. So we have that. Next example. Now this equation of the line, let me talk about something here. One of your points is given to you as a decimal. It's 24.5. That means those are fair game. Slope can be written in decimal form. I'm usually not a fan of that. But in this case, if a point is given to you in that form, I'm good with the slope being in that form as well. So this graph is showing the distance Allison hikes in X amount of hours. So it's basically distance equals rate times time. It's miles per hour. How fast is she hiking? So during her hike, she starts no time, no mileage. That's your y-intercept. Y-intercept is 0. We need to find m. So we use our points. Again, we can't really use the counting process because of what we have, especially with the value that we have. So we got to use our slope formula. Well, this one's an easy one. 24.5 minus 0, then 7 minus 0 is just 24.5 over 7, which happens to be 3.5. And I'm going to use that. I don't want to use a decimal within a fraction. I want to use 3.5. I want to use that b. Well, do we need to plug in this b as 0? No. So our formula, our equation is just y equals 3.5x. What that slope is representing is how many miles she's walking per hour. All right, so she walks 3.5 miles per hour. That's what that slope represents. Now, how long does it take Allison to hike 14 miles traveling the same rate? Now, X represents time. We know miles, which happens to be the y values you can see there. So we actually plug it in for y, solve for x, divide by 3.5, and x equals 4 hours. It takes her 4 hours to walk 14 miles. And that's her answer. That's it for the beginning portion of the modeling linear equations.